Hello mates, in the previous video I said we are going to start on coordinate systems. I've already written the topics that are going to be there in this section, the coordinate systems. The coordinate systems we are going to consider for Earth. You know that terrestrial is anything to do with Earth. Anything to do with Earth is terrestrial. We can talk of terrestrial rocks. Those are rocks that are found on Earth. Terrestrial species, they are species that are found on Earth. And then celestial is anything that has to do with the heavens, I can say the heavens, with the skies. These are celestial. So we talk about celestial bodies, which encompass stars, planets. Our sun definitely, because it's a star. So celestial bodies are things that we see in the heavens when we look up. Those are celestial bodies. So now under terrestrial in the coordinate systems, we have only one coordinate system on Earth. We use the longitude and the latitude system. That's the system that we use on Earth. So under terrestrial, when we're doing coordinate systems, we are going to do the longitude and latitude system. Under celestial, we are going to discuss the vertical system. We'll go into the first equatorial system, and we'll go into the second, and then the final one, the ecliptic system. You'll see the differences as we discuss them. You'll see the obvious differences between. Is it between? No. That's wrong English. You see the differences among these four coordinate systems. Because as time went by, people refined their systems, and you see their refinements as I explain them when we do the celestial systems. So I think without wasting time, let's start on the terrestrial system. It's better starting with the terrestrial, because charity begins at home. So let's begin with our Earth. Terrestrial system. And as I mentioned, the terrestrial system is the longitude and latitude system. We are going to see what these terms mean, longitude and latitude. So first, let's just describe a sphere. What happens in a sphere? When we describe what happens in a sphere, it will be easy for us to implement the knowledge to Earth when we're discussing this system. So let's take a sphere. Imagine this is a sphere. If that is a sphere, and imagine that I put a wire inside the sphere. Imagine it's an orange, and then I pierce the orange with a straight wire like this. When I pierce the orange with a straight wire, that goes right through the center like this. This wire is called the axis of the sphere. It is where everything, I can say it's where everything hinges, or where everything rotates. If I'm to rotate the orange like this, it's going to rotate around this. It's going to rotate around this axis. So this axis is sort of a line where this sphere will rotate, and it goes through the center like that. So now we are going to discuss. There's something called a great circle. There's something called a great circle. What a great circle basically is, if you see this axis, and then I tell you, okay, take a knife, hold your orange, and make a clean cut that passes through this axis. Make a clean cut that passes through this axis like this. And then when you take the half of the orange and you look at it like this, you turn it and you look at it like this, there will be a circle. There will be a circle with a center here. There will be a circle like this. That circle is what is called a great circle. It's what is called a great circle. So let me repeat that again. Imagine you have a full orange like this, and then I ask you to take a knife to cut the orange, passing through the axis like this, to cut the orange like this. When you look at it from the side like this, you're going to see a circle. When you see that circle that you see is called what? Is called a great circle. So let's let's get into the what? Into the definition of a great circle. When okay, let me draw it. When you cut the orange, you have a circle that is like this. And it's difficult for me to draw on a 3D diagram on a 2D plane. But this part here is the part that is behind. It's the part that is behind. And this is the axis that is right there in the middle. And this part is is facing this side. So let me bolden this part here. Let me not dash it. Let me make it solid like this. And then the dashed one is the one that is going behind the what? Is the one that is going behind the sphere. Is the one that is going behind the sphere. I hope you can see that. So when you cut like this, we are going to take off this top part here. But when we look at it, we are going to see a circle that is this bolden part and this dashed. That's how when we look at it like this will be the bolden part, and then this will be the dashed part. So that's what I mean, that this one will be a circle. And you see the intersection of a sphere, the sphere, and a plane, intersection of a sphere and a plane whose radius is not necessarily equal to the radius of the sphere. Now let's look at that kind of plane, because this is a plane. Can you see? A plane is when you clean cut something. When you let's clean cut our orange. When you clean cut our orange, this circle here makes a plane. It makes a plane, and that plane, that plane that contains this axis is called a great circle. We just think of great. It is the largest circle you can come up with in a sphere. So now, this sphere obviously has a known radius. So with a plane through the center of the sphere, this plane will be through the center of the sphere. We get a what? A great circle. So this great circle is a plane through the center. So great circle comes when the plane through the center of the sphere let me just put that in layman's language for easy understanding. So when the plane through the center makes a circle, that circle is what? Is a great circle. But there are other circles that we can make here. Imagine I cut only the top part off. You know, in orange we have something on top here, and I do not want to eat that. And then I say, no, let me take my knife and then just cut the top part off because I don't want to eat it. When I cut the top part off, I'm going to create a circle like this. I'm going to create maybe a circle like this. But can you see this circle is not going through the center? So it cannot be a great circle because it's not going through the center. And that is the difference between a great circle and just a normal circle that you have cut out. A great circle has to pass is made up of a plane that passes through the center. This one is a plane, yes, but it's not passing through the center, so it is not a great circle. So it's not a great circle. Even another plane, I want to be stingy. My friend asked for a piece of orange, and then I cut him. I cut the orange at this part here. I cut the orange at this part. I'm very stingy, and then I just give my friend this part, and I remain with this part here. Can you see when I cut it, I also make a plane, and then there's a circle there where I've cut, but this circle is not passing through the center, so it cannot be considered a great circle. A great circle is created when a plane cuts through the sphere, through the center of that sphere. So that's where we only get a great circle. So now, as you can see, the radius of a great circle is equal to radius of the sphere. And I'm just going to say r, because r is going to be my radius of this sphere. Radius of a great circle is equal to radius of a sphere. Maybe from this angle it will be difficult for you to tell, but look at this. If this length here, This length here, that I put the curly bracket, this length here is the radius of this circle, this great circle that I've drawn, right? And can you also see that it is the radius of the whole sphere? So radius of a great circle is equal to radius of the sphere. Now that we've discussed a sphere, a normal sphere, without talking about Earth or anything, this was just an orange. Let's take the concepts from that orange to apply it to Earth. Now imagine this is Earth. Imagine that is Earth. Let me just draw in our Africa just so you see what I'm trying to. Okay, this looks like Africa. I don't know. This looks like Africa, and Madagascar is here. And we have our Europe on this side, and we have Saudi Arabia here. And our India will be here on that side, and our Australia is here. And then here we have our South America looking like Africa on that side, and our North America will be somewhere there. So imagine that is our Earth, that is our globe, and imagine this is a circle, a sphere, not a circle. Imagine this is a sphere. If that is a sphere, on Earth, imagine now instead of putting a wire like this, on Earth we have an axis like this that goes right through the center of the Earth, and this is not on the surface, it's right inside Earth. Imagine this is Earth, it's right inside Earth like that, and then we're just looking at it from an angle like this. We are looking at it from an angle like this. So I'm just drawing the dotted line to show that it's going right through inside Earth like that. It's going right through inside Earth like that. So and then this center is the center of the Earth, right in the center of the sphere. It's not the center of the surface. This is not in Africa. It's right in the center of a sphere. I cannot draw the center. It's somewhere inside here, but I cannot draw it, so I'm just putting it there, but it's not on the surface. It's inside the core of the Earth. So now imagine now I draw a great circle. I'm asked to draw a great circle, and then I draw a circle like this. There's a line that's going to come. There's a line that's going to come on the surface here on this side, and then there's a line that's going to go behind Earth. It's going to go right behind Earth. So this line is going like this, and then going behind, and then coming back like this. So that's what happens when I cut. If I'm to cut Earth like this, cut it like this, I'm going to have a line that's going to be drawn, and that line is going to create a circle. So let me simplify the diagram without putting the continents. So if I'm not to put the continents, this will be the center of the Earth. This will be the great circle that I have just drawn, and then it goes behind the sphere. So it's a great circle. It is a great circle because its plane is passing through the center, and this one will be the radius. This one would be the radius of what? Of our Earth. That's the radius of our Earth. So now this one here, this one will be the axis, and we are going to give this axis. We are going to define how to get this axis. We're going to define how to get this axis on Earth just now. So now, can you see the what? When we discussed the sphere, the diameter of the sphere, the diameter of the sphere, which is perpendicular to the plane of the great circle, is called the axis of the great circle. So consider this circle here, and they're saying the diameter of this sphere, which is perpendicular to the plane of the great circle. Can you see this is the plane? So which one is perpendicular? Obviously, it's going to be a diameter that is like this, which is at 90 degrees. I hope you can see that. Now the colors, they're just black. It's now black all over. But I've drawn this diameter here because they said the diameter that is perpendicular to the plane, of the great circle, is called the axis. It's the axis of this particular great circle. So all great circles have different axes. If the great circle was flat like this, its axis would be perpendicular, like its axis would have been like this, because it is the diameter that is perpendicular to the plane of this. So it would have been like this. If our great circle was like this, the perpendicular axis would have been something like this. So that is one thing we need to note, because we're going to apply it when we're talking about the terrestrial sphere Earth. So here we've talked about what? The axis. The axis being the diameter that is perpendicular to a great circle. So now this axis here, it cuts the sphere in 2 points, known as the poles of the what? Known as the poles of the great circle. The axis cuts the sphere in 2 points, known as the poles of the great circle. So can you see here? This great circle created our axis like this. But this axis is going to cut our sphere at this end and at this end. Those two ends are called poles. So this is pole number 1, P-O-L-E, and this is pole number 2. So that was in a normal sphere. But let's bring this concept back home to what? To our terrestrial sphere, or to our Earth. Let's bring this point home. On Earth, we have a great circle called the equator. We have a great circle called the equator, like this great circle. So this great circle called the equator, for any great circle we have an axis that is perpendicular to the what? To the plane of that great circle. So here we have an axis now. This is the axis that I created. So this is now how to find that axis. This axis that I created, that I put here, is perpendicular to the plane of the equator, and this axis cuts this Earth at 2 points, this point and at this point. Just as we noticed for a normal sphere, we noticed that we are told that the axis of a great circle cuts the sphere at 2 points, the poles. It's the same thing on Earth. On Earth, the axis of the equator great circle cuts the Earth at 2 points, this point and this point. So now let's give names to those 2 points. On Earth, we are lucky that those 2 points have what? Have names. So this equator, let me give it's called the terrestrial equator. For us to differentiate from any normal equator, it's called the terrestrial equator or the geographical equator. So that is what? Our terrestrial equator, which has this axis being what? Being perpendicular to the plane of this great circle called the terrestrial equator. And it's cutting our Earth at 2 points, 1, 2, called the poles. But the poles have names, and we are going to give them names. The top pole here, that is in the first, before I even say the northern hemisphere, the equator cuts our Earth into 2 hemispheres. You know, a hemisphere is half a sphere. So there's going to be this top sphere and this bottom sphere. The top sphere is called the northern hemisphere. So this top part here is the northern hemisphere, and then this bottom part here is called the southern hemisphere. So the pole that lies in the northern hemisphere is called the north geographical pole, and the pole that lies in the southern hemisphere is called the south geographical pole. It's called south geographical pole. This one is north geographical pole. So these are the 2 poles that we have on Earth, and they were given names due to the what? To their location. This one is located in the northern hemisphere, so it's called the north geographical pole. This one is located in the southern hemisphere, so it's called the southern geographical pole. So now that we've discussed our celestial sphere, now that we've discussed our sphere, and we have come up with a great circle for Earth and the poles, in the next video we are going to take the coordinate system for Earth further and seeing how to define it. So stay tuned for that video.